Mr. Wright here, and welcome to another Mr. Wright IGCSE Maths film. In this film, I'm walking through lots of past IGCSE questions on mixed numbers. Now, this is a really common topic in the exam, and you would do well to be really fluent at this before you sit the papers for real. You can click the link in the description of this film and download the questions, and then you can have a go at the questions and then watch the film, or you can watch the film whilst you're working on the questions and we can be working at them alongside each other. Right, good luck. Let's get on with the maths. Right, let's get started. Operations with mixed numbers. Now, all of these are past IGCSE questions. Let's have a look at question 1. Show that the left-hand side equals the right-hand side. Well, I'm simply going to work out what the left-hand side equals. So I've got the 4 plus the 3 gives me 7 wholes, and now I've got 2/3 and 4/5. Thirds and fifths, I'll change those into 15ths. Times by 5, 2 5s are 10, times by 3, 4 3s are 12. That gives me 7 and 22/15ths, which is 8 and 7/15ths. And that is question 1 done. Question 2. This time I've got a division. Now, when I divide mixed numbers, I start by turning the mixed numbers into top-heavy. So 6 4s are 24, plus the 3 is 27 over 4, divided by 2 7s are 14, plus the 4 is 18 over 7. Right, keep, change, flip. Now look for cancelling. Nothing in the 4 and the 7. 3s, 9s go in, don't they? 18 and 27. So 9 goes twice and 9 goes 3 times. Top times top, 3 7s are 21. Bottom times bottom, 4 2s are 8. 21 over 8, that's 2. 8 goes in twice, doesn't it? Remainder 5. 2 and 5/8. And yes, that's what I was asked to do. Question 3, dividing mixed numbers. Right, so I'm going to turn them both into top-heavy, into improper. 2 7s are 14, plus the 4 is 18 over 7, divided by 1 times 8 is 8, plus the 1 is 9 over 8. Now keep, change, flip, cancelling. 7 and 8, nothing goes in there. There isn't a common factor, but 9 goes into 9 once, 9 goes into 18 twice. Top times top, 16. Bottom times bottom, 7 times 1 is 7. 16 sevenths, well, 7 goes into 16 twice, remainder 2. So that's my answer. Let's just look at the question. It says, show that the answer to this calculation is 2 and 2/7, and yes, we've done that. And that is question 3 done. Question 4, more dividing mixed numbers, obviously very popular with the examiners. Turn these mixed numbers into improper. 4 3s are 12, plus the 2 is 14 over 3, divided by 1 times 6 is 6, plus the 5 is 11 over 6. Keep, change, flip. Look for cancelling. 3 goes into 3 and 3 goes into 6. So 3 goes into 3 once, 3 goes into 6 twice. 2 14s are 28. 1 times 11 is 11. 28 over 11, well, 2 11s are 22, aren't they? So that goes twice. Remainder 6. Now let's look at the question. It says, show that the calculation on the left equals 2 and 6/11, and look at that. It does, and I've shown that to be the case, and that's question 4 done. Question 5. Right, getting slightly bored of division now. Let's hope it's the last one for a while. Turn these mixed numbers into improper. 4 3s are 12, plus the 2 is 14 over 3, divided by 1 times 9 is 9, plus the 1 is 10 over 9. Keep, change, flip. Cancelling. 14 and 10, they have a common factor. 2 goes into those. 2 goes into 10 5 times. 2 goes into 14 7 times. 3 and 9, 3 goes into 3 once. 3 goes into 9 3 times. 7 times 3, 21. 1 times 5 is 5. 21/5. How many 5s in 21? 4 with 1 left over. 4 and a 5th. Check the question. Have we shown that 4 2/3 divided by 1 1/9 equals 4 1/5? Yes, we have, and that is the question finished. Question 6. Look at that. It's not a division, it's subtraction. So I'm going to do the wholes first. So 5 take away 2 gives me 3. And now I've got a third take away 6/7. Right, so that's going to be 3. Now these thirds and sevenths I have to change into the same thing. I'm going to change them both into 21ths. The 3's been multiplied by 7 to get 21, so I must multiply the top by 7. And similarly, the 7 here has been multiplied by 3, so I must multiply the top by 3. So I've got 3, and now I've got 7 21ths minus 18 21ths. 7 minus 18, that's minus 11. So I've got 3 and minus 11 21ths, which equals 2 and 10 21ths. Now, how have I done that? Well, if you imagine 3 cakes, and you take away 11 21ths, so I'm going to take away from here 11 21ths. If I take away 11 21ths, I'll be left with 10 21ths. So altogether, I'm left with 1 whole, 2 wholes, and 10 21ths. Or alternatively, if you've got a calculator at hand, you could simply type in 3 minus 11 over 21, and that would tell you that the answer was 2 and 10 21ths. That's question 6 done, because I've shown that the left-hand side equals 2 and 10 21ths. Question 7, it's a division again. They obviously think division are worth testing more than the other operations. So I'm going to turn 3 and 5/7 into an improper fraction. 3/7 are 21, plus the 5 is 26 over 7. Divided by 1 times 8 is 8, plus 5 is 13 over 8. Keep, change, flip. Okay, cancelling. Ooh. 13 goes into 13, and 13 goes into 26. 13 goes to 13 once. 13 goes into 26 twice. 2 times 8, 16. 7 times 1 is 7. 16 over 7. How many 7s in 16? 2 and 2/7. Now let's check the question. Have we shown that the left-hand side equals 2 and 2/7? Yes, we have. And that's question 7 finished. Question 8. Addition of mixed numbers. Right, when we add, we do the wholes first. 2 plus 3 gives me 5. And now I've got 2/3 plus 3/4. 5. Right, thirds and quarters. Need to change them both into the same thing. I'm going to change them both into 12ths. Change the thirds into 12ths. I've multiplied by 4. So I'll do 2 times 4 as well. Gives me 8. Second fraction, I've multiplied at the bottom by 3, so I must do the same to the top. 3 3s are 9. So I've got 5 wholes and 17 twelfths. Now this 17 twelfths, that's more than a whole, isn't it? That's 1 and 5 twelfths. So altogether here, I've got 6 and 5 twelfths. Now let's check the question. Show that the left-hand side equals 6 and 5 twelfths. Yep, I've done that. And that's question 8 done. Question 9. Oh, good. We're going to finish with a division. What a surprise. Right. So when I divide, I turn the mixed numbers into improper. 4 times 3 is 12, plus 2 is 14 over 3, divided by 1 times 5 is 5, plus the 1 is 6 over 5. Keep, change, flip. Look for cancelling. 5 and 3. Look at this. 6 and 14. They have a common factor because 2 goes into both of those. 2 goes into 6 3 times. 2 goes into 14 7 times. Top times top. 7 5s are 35. Bottom times bottom. 3 3s are 9. 35 ninths. How many 9s in 35? Well, 3 9s are 27, which would leave me with 8 ninths. Now let's check the question. Show that the calculation on the left equals 3 and 8 ninths. We've done that. And that is the end of question 9. Well done for making it through to the end of all those questions, and I hope you found the film useful. If you've got any questions or you'd like some help with anything, leave a comment in the comments, and of course, I'll respond. If you found the film useful, please hit like. And if you are finding my content is helping your maths, then subscribe to the channel. Right, see you in the next film.